Question number 69. X is the product which is obtained from propane nitride treated with the stannous chloride in presence of hydrochloric acid followed by hydrolysis. Hope you understand. We are talking about a Stephen reduction. And Y is the product which is obtained from butene undergoing ozonolysis followed by hydrolysis. From the following, which product is not obtained when 1 mole X, 1 mole Y react with each other in presence of alkali followed by heat? That is the question. Okay. So, what exactly is X? Propane nitrile. CH3, CH2, Cl. Propane nitrile is treated with the SnCl to HCl, that is Stephen reduction, and the result known to all. It is CS3, CS2, CHO. The final result after hydrolysis, first you get imine. Hope you remember, it's a partial reduction. First you get imine, and from there it is converted to aldehyde. So you get propanol. Idana X. Okay. Now, Y is the product obtained from butene undergoing ozonolysis. CH3CH double bond CH3 treated for ozonolysis. Everybody remember, it's going to break over here and you get the product like this. You will be getting 2 mole of ethanol. You get 2 mole of ethanol, and that is Y. So X is propanol and Y is ethanol. Now X and Y react together in presence of alkali, that is cross aldol condensation, isn't it? Cross aldol condensation. The question is, which of the following product is not obtained? Which of the following product is not obtained? That is the question. Suppose they condense, what do you get? CS3, CHO condenses with CS3, CH2, CHO. Suppose it is condensing over here. Hope you remember, we are talking about a cross aldol condensation. And what is the result of cross aldol condensation? From the carbonyl center, one oxygen and alpha hydrogen, alpha carbon, alpha hydrogen is removed as water, and you get alpha, beta, unsaturated aldehyde or ketone. That is the final result of aldol condensation. In this case, the final result taken combination, it will be CH3CH, CH3, CHO. This is what the result. CS3, CH, double bond, CH3, CHO. What is that compound? 1, 2, 3, 4. That is 2-methyl but-2-enol. 2-methyl but-2-enol. So this will be a product obtained. This will be a product obtained. Okay. B1 which is not obtained. That is the question. Suppose we take the opposite combination. That is CH3, CH2, CHO plus CH3, CHO, if it is combining, is going to add over here. I mean condense over here. You will get CH3, CH2, CH double bond, CH, CHO. CH3, CH2, CH double bond, CH, CHO. That means 1, 2, 3, 4, 5. That is pent-2-enol. Pent-2-enol. That is another product. Pent-2-enol. That is another product, right? Now, what about getting 2-methyl pent-2-enol? 2-methyl pent-2-enol. Is there such a possibility? 2-methyl pent-2-enol. Can we get that one? So we got two product. Another product you can get is self-condensation. This is cross aldol condensation. There can be self-condensation. CH3CHO plus CH3CHO. The product will be CH3CH double bond CHCHO. That is but2-enol. 1, 2, 3, 4. But2-enol. Not in the choices. Not in the choices. Suppose we take the self-condensation of propanol CH3 CH2 CHO plus CH3 CH2 CHO. Imagine it is condensing over here. What do you get? You get CH3 CH2 CH double bond C CH3 CHO. CH3, CH2, CH double bond C, CH3, CHO. That is 1, 2, 3, 4, 5. 2-methyl pent 2-enol. 2-methyl pent 2-enol. This is possible. So definitely our answer should be first choice. Our answer should be first choice. This will be the answer. Because when two different aldehydes capable of contributing as an alpha hydrogen, when undergo condensation, there can be 4 products. What are the 4? We have studied that. What are the 4 products? It is actually described in the textual content, isn't it? When you have 2 different aldehydes, both are having alpha hydrogen atom, A1 and A2, both are having alpha hydrogen atom, you will get 4 products. Product number 1, it is A1 condensation product. Product number 2, it is A2 condensation product. Product number 3, A2 condensation product. Product number 4, A1 condensation product. These are the 4 products you can get. Right? You see, this is number 1, A1. This is number 2, A2. This is number 3, A1, A2. This is number 4, A2, A1. This is the possibility. And that possibility is not satisfied by this. This is not in the picture. Right? So other choices are available. And the question is, which is not obtained? Which is not obtained? 3-methyl but2-enol. This is but2-enol. 3-methyl but2-enol. This is not possible. 3-methyl but2-enol. And this is possible if you take a condensation between, you can just have a look at that molecule. If you take the condensation between acetone and ethanol, you will get this. If you take the molecule, say acetone, CH3COCH3 plus CH3CHO. If you take acetone and ethanol, the product will be this one. Make it clear. It is CH3, CH3CHO. So this will be the product if there is a condensation between acetone and ethanol, right? And that is not in our description here. So look at the question. First, we need to understand what is X and what is Y. And using X and Y, what will be the possible combinations and what is the non-possible combination which we are asked to identify from the question. So with the Stephen reduction, we understand the molecule is propanol. With the ozonolysis of but2-ene, we understand the molecule is Y is ethanol. And propanol, ethanol, what will be the possible combinations and what is the non-possible combination which is, non-possible product which is to be selected as the answer. Okay, next question. Question number 70. The correct sequence of reagents for the above conversion X to Y. X to Y. Let's verify the first combination. You have sodium ethoxide. So this with the sodium ethoxide, that is alcoholic NaOH, NaOET, there will be elimination reaction. This bromine and this hydrogen will go and you will get alkene. You will get alkene. Then it is, so that is over. Then it is diborane, hydroboration oxidation reaction. Then it is hydroboration oxidation reaction. Everybody remember, you will get alcohol at this carbon. Hope you remember the importance of hydroboration oxidation reaction. You get a alcohol at a terminal carbon. The product seems to be opposite to Markovnikov addition. Hydroboration oxidation. So first one, it is dehydrohalogenation elimination reaction. Second one, it is hydroboration oxidation reaction. Now third one, John's reagent. John's reagent will give you oxidation. This will be converted to COOH and you get the product. And in fact, first choice itself is the correct answer. First choice itself is the correct answer, and that gives you the correct combination to get the requisite product X converted to Y. I repeat, using NaOET, you get elimination reaction happening, and here you get a double bond. Okay, and then it is hydroboration oxidation. You get OH at the terminal carbon, and then John's reagent. John's reagent is oxidizing alcohol to carboxylic acid, right? And hence X is converted to Y. First choice itself is the correct answer. You may please verify why the other choices are not coming. For example, suppose you are taking, say, third choice. Third choice, John's reagent. John's reagent straight away applied here. What can be the result? You get straight away benzoic acid, isn't it? You get straight away benzoic acid. Suppose you take option 4. Option 4, first you take hydroboration oxidation. Hydroboration oxidation has nothing to do over this X because it is working on a alkene and the OH group is attached to the terminal carbon atom, right? So any other choices? Option 2, for example, first one with the aqueous NaOH, this bromine will be converted to OH group. Then John's reagent, you get maybe that secondary alcohol converted to ketone. Anyway, those strategies in the other choices, the combination of reagents in the other choices will not satisfy getting that result. First choice will do. Okay, next question. Question number 71. The compound A, C8H8O2, C8H8O2 react with acetophenone to form a single product via cross-aldol condensation. The compound A on reaction with the concentrated NaOH forms a substituted benzyl alcohol as one of the two products. The compound A is, the compound A on reaction with the concentrated NaOH forms substituted benzyl alcohol as one of the product. Compound A is, okay, and that react with the acetophenone to form a single product via cross-aldol condensation. So we need to understand what exactly A is. 2-hydroxyacetophenone. 2-hydroxyacetophenone, option 1. This is 2-hydroxyacetophenone. Acetophenone 2-hydroxy. This will not satisfy this reaction. See that second part of the reaction? Second part of the reaction, it is Cannizzaro reaction, isn't it? This is not satisfying Cannizzaro reaction. So that is out. This is out because it is acetophenone. 4-methoxybenzaldehyde. 4-methoxybenzaldehyde. Option 2. 4-methoxybenzaldehyde. 8 carbon, okay. 8 hydrogen, okay. 2 oxygen, okay. This will give you Cannizzaro reaction, and this when treated with the concentrated NaOH, the result will be, there is Cannizzaro reaction. You get CH2OH, that is substituted benzyl alcohol, and sodium salt of benzoic acid. Again, substituted. This I have written wrong. OCH3. So this is Cannizzaro reaction, and this part of the statement is satisfied by option 2, 4-methoxybenzaldehyde. Okay, now that when treated with acetophenone, this when treated with acetophenone, this is acetophenone, this is acetophenone, there will be a single cross aldol product. Yes, there will be a single cross aldol product. Have a look at that reaction. I will write as a sequence to understand. CHO OCH3 plus acetophenone, CS3CO benzene ring. Imagine it is undergoing a condensation over here. This oxygen and this hydrogen out as water. You will get the product, the one and only product. You get only one product as this alone having alpha hydrogen atom. This alone having alpha hydrogen atom, you get only one cross aldol product, and the product will be like this. Here you have CH, OCH3, and it will be double bond, CH, CO benzene ring. This is the one and only cross aldol product you get. So that means our answer is second choice. That means our answer is second choice, right? You see, the formula is matching, and all given conditions are perfectly matching for the molecule given in option 2. Okay. What about the other options? 4-hydroxybenzaldehyde. Why not? Why not 4-hydroxybenzaldehyde? This is benzaldehyde, 4-hydroxybenzaldehyde. It is not matching with the formula. There are 8 carbon atoms. This contains only 7 carbon atoms. All other parameters are okay. I mean, all other descriptions are matching for third choice, but it's not matching with the formula. Formula says 8 carbon atom, right? Here it contains 8 carbon atom. What about the other one? 4-methyl benzoic acid. See, benzoic acid, it cannot undergo Cannizzaro reaction. It cannot undergo the reaction like cross aldol reaction. So that is straight away out. The first deleted option we can say it is fourth choice, isn't it? So that's about, if you take a first choice, this is first choice. This is okay with the formula, but the reactions are not perfectly matching, while everything is matching for second choice. Okay. Next question. It's about matching the list. List 1 reagents to be matched with the name of reaction involving carbonyl compounds. That is the question. Okay. Let's try. A matches with the Wolff-Kishner reduction. A matches with the 3, isn't it? NH2, 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 KOH, Wolff-Kishner reduction, hydrazine. See, the given carbonyl compound treated with the hydrazine, you get a corresponding hydrazone, which is further heated with ethylene glycol and KOH, getting the reduction reaction. The CO group is converted to CH2 group. Hope you remember. This is what the reaction. CO group is converted to CH2 group. First treating with NH2, NH2, and then treating with ethylene glycol and KOH. So that is what the matching. A with 3. A with 3, 2 choices are out. Then ammoniacal silver nitrate. Ammoniacal silver nitrate is Tollens reagent. Ammoniacal silver nitrate is Tollens reagent, and we get the answer Option 4, correct answer. So checking first and second choice, we get the answer. Checking first and second choice, we get the answer. Okay. What about third one? Ammoniacal copper sulfate, sodium, potassium tartarate. That is Felling's solution. That is Felling's solution. So this matches with the 4. And zinc amalgam HCl, that is Clemmensen reduction, matches with the 2. And this is again Clemmensen reduction using zinc amalgam HCl. So that's a very simple question based on the very simple reagents that we are comfortably in touch with continuously. Right? അടുത്ത ചോദ്യം. Again, match list ആണ്. List 1, list 2, reagents, reaction name. Reagents, reaction name. That is what asked. Okay, right. What is the matching with the first one? Hydrogen, palladium, sulfate. Hydrogen, palladium, sulfate. Rosenmund reduction. Hydrogen, palladium, sulfate. It is Rosenmund reduction, where acid chlorides are converted to aldehydes. Acid chlorides are reduced to aldehydes using Lindlar's catalyst. Palladized charcoal or palladium with barium sulfate, poisoned with sulfur or quinoline, or with calcium carbonate, palladium with calcium. See, the active site of palladium is blocked. Active sites are reduced by adding with charcoal or barium sulfate, and it is slightly poisoned with sulfur or quinoline. Lindlar's catalyst. Lindlar's catalyst is effectively converting aldehydes into, acid chlorides into aldehydes, preventing the further reduction towards alcohol. That is what the reaction, very popular reaction, Rosenmund reduction. So A2 means this is out, this is out. What about B? SnCl to HCl, that is Stephan reduction. SnCl to HCl is Stephan reduction, and we get the answer. Once again, based on the very popular reagents and very popular reactions. Direct, simple question. Okay. Is the other matching also correct or not? CrO2Cl2 carbon disulfide, that is very popular Ettards reaction, C1, and COHCl anhydrous AlCl3, that is Getterman-Koch reaction. What is Getterman-Koch reaction? Benzene treated with COHCl AlCl3, you get a benzaldehyde. Ettards reaction. Ettards reaction, toluene is treated with a chromyl chloride. You get a chromium complex, which upon hydrolysis we get a benzaldehyde. Right? Controlled, oxidation reactions. Okay? All non-reactions and very popular reactions, very popular reagents only. Okay? Next question. Question number 74. An organic compound P of molecular formula C6H12O3 gives positive iodoform test but negative tolerance test. Iodoform test is positive. Iodoform test is positive while tolerance test is negative. Iodoform test positive, tolerance test negative. Okay. P is treated with the dilute acid, it produces Q. Q gives positive tolerance test and also iodoform test. So Q gives positive tolerance test and also iodoform test. Structure of P is. So P give positive iodoform test. Yes, suppose if we take first option, this give positive iodoform test, you can very well understand a methyl keto group. A methyl keto group is available. A methyl keto group is available. Any molecule containing methyl keto group or methyl carbinol group, which is not a derivative of acid, can give you iodoform reaction, right? So a molecule which contain CH3 CO group, that is methyl keto group, CH3 CHOH group, that is methyl carbinol group, which is not directly interacting as a acid derivative. So acids and derivatives will not give this reaction, right? Because acids, acid chlorides, anhydrides, they may contain methyl keto group, but they are the oxidized final product, and the halform reaction is an oxidation reaction. Okay, so those molecules which contain methyl keto group or methyl carbinol group, this is methyl keto and this is methyl carbinol. Other than acids and derivatives, when treated with halogen and alkali, you get the product haloform, and the reaction is called haloform test. With the iodine and NaOH, you get the iodoform test. So this contain methyl keto group, so it will show positive iodoform test. And what about tolerance test? Gives positive iodoform test but negative tolerance test. When P treated with the dilute acid, it produces Q. Q gives positive tolerance test and positive iodoform test. See, here upon hydrolysis, this will be converted to OH group, and that is vicinal OH group. So the given molecule, when undergo hydrolysis, you will get CH3, CO, CHOH, CH2OH, right? That acetal group is hydrolyzed, just imagine. That ether group is hydrolyzed, just imagine. You get a vicinal diol. Now you see, this is the compound Q. Q give positive tolerance test and iodoform test. Wrong. It cannot give you positive tolerance test. Tolerance test is given by aldehydes. Okay. What about the second molecule? Second molecule is the answer, it seems, because it is containing methyl keto group, so iodoform test is possible. It will give you iodoform test. And upon hydrolysis, say with the HCl, you will get CH3, CO, CH2, CHOH. This is what you are going to get. And I am sure all of you remember, this will be easily converted to aldehyde, because gem diols are unstable. And it will undergo a removal of one water molecule. H2O will be out. You get a aldehyde. Now this is Q. Q can give you iodoform test. Q is able to give you iodoform test because here you have methyl keto group. And Q can give you tolerance test because you have an aldehyde group. And this is P. P can give you iodoform test because there is methyl keto group. And it will not give you tolerance test. Because this cannot provide tolerance test. But upon hydrolysis, that group will be converted to aldehyde group. So before hydrolysis, the compound P will give you iodoform test but not tolerance test. After hydrolysis, that CHOH2 part, that CHOCH3 two times, gem alkoxy group will be converted to aldehyde group, and that aldehyde group will be able to give you tolerance test also. Okay, so the result is second option. So our answer will be that one. This is our answer. And you can verify what's happening with option 3. Option 3, upon hydrolysis, have a look at. It's capable of giving iodoform test initially. But after hydrolysis, what you're going to get is CH3CO, and these two groups, when hydrolyzed, you will get that also converted to keto group. You don't get a tolerance test. Tolerance test is given by aldehydes, right? What about option 4? Option 4. Option 4, you see here, you don't get, you see this, you don't get iodoform test. This is not having any methyl keto group. It is not having any methyl keto group. This is compound P. P is capable of giving tolerance test and is unable to give iodoform test. So that is also out. Fourth choice, there is an aldehyde group in P. So it is able to give tolerance test and it is unable to give iodoform test. So that option is also out. I hope it is clear. Okay. Next question. Total number of alkali insoluble solid sulfonamides obtained by reaction of given amines with the Hinsberg reagent. I am sure all of you remember regarding Hinsberg test, Hinsberg reagent. Primary, secondary, tertiary amines are distinguished and tested with the Hinsberg reagent. Hinsberg reagent means benzene sulfonyl chloride or para-methyl benzene sulfonyl chloride, tosyl chloride, right? When you take a primary amine, it is reacting with the Hinsberg reagent, you get a solid product which is soluble in alkali. If you take a secondary amine, it is reacting with the Hinsberg reagent, you get a solid product which is insoluble in alkali. And a tertiary amine does not react with the Hinsberg reagent. Everybody studied that reaction. Okay. So what is the question here? Total number of alkali insoluble solid sulfonamides obtained by reaction of given amine with the Hinsberg reagent. So we are checking secondary amines. If you take a secondary amine when treated with the Hinsberg reagent, this is Hinsberg reagent, there will be HCl out and you are getting a solid product. This is the solid product obtained and that is called NN dialkyl benzene sulfonamide. N, N dialkyl benzene sulfonamide. This is a solid product and this is insoluble in alkali. This is insoluble in alkali because over here you don't have an acidic hydrogen. That nitrogen lacks any acidic hydrogen. Suppose it was primary amine, there would have been one hydrogen. And that acidic hydrogen make it soluble in alkali. While here, secondary amine, when treated with the Hinsberg reagent, you get a solid product and that is insoluble in alkali. Is it clear? So we want to identify from the given list how many secondary amines. That is our question. How many secondary amines? That is our question. Aniline is primary amine. N-methyl aniline, this is a secondary amine. Methanamine, a primary amine. N-dimethyl methanamine is a tertiary amine. N-methyl methanamine, this is a secondary amine. Phenyl methanamine is a primary amine. N-propyl aniline, a secondary amine. N-phenyl aniline, a secondary amine. N-dimethyl aniline, a tertiary amine. Allyl amine, a primary amine. Isopropyl amine, a primary amine. So the answer should be 1, 2, 3, 4. First choice should be the answer. There are 4 secondary amines. And I think many of you are aware of, almost all of you are aware of, identifying secondary amine from the IUPAC naming is very, very simple. You just check with the N. N-methyl aniline, that is secondary amine. Simply aniline, primary amine. Suppose there is N, N, it will be tertiary amine. So from the name itself, without drawing the structure, you can get what kind of amine is it. It's a primary amine, secondary amine or tertiary amine. So wherever you find N, for example, N-phenyl aniline. If you look at the molecule N-phenyl aniline, this is N-phenyl aniline. This is aniline. This is aniline. And what is N-phenyl aniline? This is N-phenyl aniline. And it's a secondary amine. So from the name itself, without drawing, you can get the molecule. Without drawing the structure, you can get what kind of molecule it is. Okay. So that's the answer. So we are asked for secondary amine, and that is clear from this comment. Total number of alkali insoluble solid sulfonamides obtained by reaction of given amines with the Hinsberg reagent means secondary amines. From the list, how many are secondary amines? That is the question. Okay. Next one. Question number 76. A student has planned to prepare acetanilide from aniline using acetic anhydride. Started with a 9.3 gram aniline. However, the student has managed to obtain 11 gram of dry acetanilide. Percentage yield of this reaction is. So 9.3 gram aniline is providing 11 gram of dry acetanilide. What is the percentage yield of the reaction? Let's figure out. This is aniline. This is aniline, and that is treated with acetic anhydride, excess acetic anhydride. You will get acetanilide. This is acetanilide, NHCOCH3, acetanilide. Molar mass of aniline, C6H5, C6H5 plus NH2, 77 plus 16. So it is 93. That is the molar mass of aniline. You are taking 9.3 gram of aniline. So 9.3 gram means 9.3 by 93, 0.1 mole. That is aniline. The amount of aniline taken is 0.1 mole, 9.3 gram. It is 9.3 divided by 93, 0.1 mole. What about here? The molar mass C6H5 plus NH plus CO plus CH3 means 77, 15, 28 plus 15, 30, 58, 134, isn't it? 134, right? That is the molar mass of acetanilide, 134. Now you can see 1 mole will give you 1 mole. 1 mole will give you 1 mole. 0.1 mole will give you 0.1 mole. 1 mole aniline, when treated with the excess acetic anhydride, you get acetanilide. This is acetanilide. Acetanilide. 1 mole aniline, you will get 1 mole acetanilide. Okay. Therefore, 0.1 mole aniline, you get 0.1 mole acetanilide. That is 0.1 into 134. That is 13.4 gram acetanilide. This is what you are expected to get, provided there is 100% yield. Suppose the reaction has got 100% yield. The mass of product obtained is 13.4, but the quantity that we get is only 11 gram. So what is the yield? Percentage yield equal to obtained mass divided by obtainable maximum quantity into 100. That will give you the answer. 1100 by 13.4. That will give you the answer. 1100 by 13.4 will be the answer. Anyway, the first choice first and fourth choice are nearly out. Is it second or third? That is what you need to figure out. Second or third. That is what you need to figure out. Anyway, it's not going to be 97 because that much is not the difference. It will be option 3. Please verify that. 81.5, that will be the answer. Without a calculation, you can comment. First and fourth choice straight away out. Then there can be a confusion between here. Anyway, it's very close to 100%. So it will be nearly 82%. That will be the answer. 11 out of 13. 11 out of 13. Nearly 80%. Okay. So that will be the answer. Once again, 1 mole aniline, you will get 1 mole acetanilide. 0.1 mole aniline, because it is 9.3 gram is given. 9.3 gram is given, so it is 0.1 mole. 0.1 mole aniline, you will get a 0.1 mole acetanilide. Molar mass of acetanilide 134. So 0.1 mole means 13.4 gram is acetanilide. Theoretically, we get. But what the practical figure observed in the reaction is only 11 gram. That means it is not 100% yield. How do you find the yield? Yield will be obtained mass divided by obtainable maximum mass according to the theoretical calculation into 100. That will be the answer. Okay. You get option 3. You can verify. Right. Next question. Given below are two statements. Two statements are given. We need to verify that. Two statements are given. First statement. The dipole moment of RCN is greater than RNC. And RNC can undergo hydrolysis under acidic medium to produce RCOOH. Wrong. It's a wrong statement. RNC can undergo hydrolysis under acidic medium to produce RCOOH. It is wrong. What's happening with the RNC? RNC undergoing hydrolysis. It will break here. You will get RNH2 and HCOOH. You get formic acid and primary amine. I'm sure you might have heard about RNC in aqueous medium can give you silver mirror test. RCN cannot. RCN cannot. RNC, when treated for hydrolysis, you get silver mirror test, because RNC undergoing hydrolysis, you get RNH2 and formic acid. Formic acid is able to give you silver mirror test, right? So the first part of the molecule, first part of the question, that is statement 1, is wrong. What wrong is? Second part is wrong. What about the first part? Dipole moment of RCN greater. This is correct. This is correct. Dipole moment of RCN greater than RNC is correct. But the second part of the statement, RNC will give you RCOOH, is wrong. RNC will give you RNH2 plus HCOOH. Okay. While RCN is correct. RCN is correct. RCN upon hydrolysis is going to break here. You will get RCOOH and ammonia. That is correct. Now statement 2. RCN hydrolyzes under acidic medium to produce a compound which on treatment with SOCl2 followed by addition of ammonia give another compound X. This compound X on treatment with NaOCl NaOH gives a product that on treatment with chloroform KOH produces RNC. My God, let's try. RCN hydrolyzes under acidic medium to produce a compound which on treatment with so this is the compound obtained. RCN undergo hydrolysis in acid medium. You will get this, and that treated with SOCl2, you will get RCOCl. You get RCOCl. This is the compound followed by addition with ammonia. Followed by addition with ammonia. You will get amide, RCONH2 amide, that is compound X. Now this compound treated with NaOCl, NaOH. This compound treated with NaOCl, NaOH. NaOCl, NaOH. That is degradation reaction. That is degradation reaction. You will get RNH2. RNH2. That further treated with the chloroform alkali. This is further treated with the chloroform alkali. You will get RNC, carbylamine reaction. You will get RNC, carbylamine reaction. So this statement is perfect. Second statement is perfect. So first statement is wrong. What wrong in it is? RNC upon hydrolysis, you don't get RCOOH, you get RNH2. While the second statement, all the sequences given are perfectly correct. RCN on hydrolysis, you get RCOOH. With the SOCl2, you get RCOCl. With the ammonia, you get amide. That degradation reaction, you get a primary amine. That undergoing carbylamine test, you get isocyanate. Second statement is perfect. So first statement wrong, second statement correct. Option 2 is the correct answer. Option 2 is the correct answer. First statement wrong. That too, the second part of the first statement is wrong. Second part of the first statement is wrong. Okay. அடுத்தது. Question number 78. The correct stability order of disonium salt. Correct stability order of disonium salt. Which is maximum? Please understand, disonium salt having a positive center on nitrogen. So it is positive center on nitrogen. So electron donating group will stabilize the system. Electron donating group will stabilize the system. Please understand that clearly. As far as a disonium salt is concerned, nitrogen carry a positive charge, right? And that positive charge or cationic species is stabilized by electron donating group and destabilized by electron withdrawing group. So if it is electron withdrawing group, this will be destabilized. Imagine here you have electron withdrawing group. It is withdrawing the electron density, the charge will increase. So the positive charge, whether disonium salt or any intermediate you deal with, the stability of intermediate when you try to identify, please understand, cations are stabilized by electron donating systems and anions are stabilized by electron withdrawing systems. That is the fundamental aspect you need to understand. Okay, so here it is disonium salt and electron donating group will stabilize the system. So most stable, no doubt, it is A. Most stable, it is A because it is electron donating group. Electron donating group. And nitro-CN, they are electron withdrawing group. So after that it will be C. After that it will be C. So A maximum, then C. Because in C there is no group. While these two groups are electron withdrawing group. They are electron withdrawing group. And most electron withdrawing is this one. So B will be last. So it is AC, then it is D, then it is B. This will be the correct answer. Option ACDB. Option 2 will be the correct answer. Right? A maximum because alkoxy group is electron donating group. After that it is C because no group is present. And after that it will be B and D because they have electron withdrawing group, of which nitro group is highly electron withdrawing compared to CN group. So CN group coming compound D will be next and last will be B. Right? That is the choice. Clear? Fine. Next question. 79. A student has been given a compound X, molecular formula C6H7N. X is sparingly soluble in water. However, on addition of dilute mineral acid, X becomes soluble in water. X, when treated with the chloroform and alcoholic KOH, Y is produced. Y has a specific unpleasant smell. That means we are talking about carbylamine test. So X should be a primary amine. X should be a primary amine. On treatment with the benzene sulfonyl chloride, X gives compound Z, which is soluble in alkali. The number of different hydrogen atom present in Z is. Number of different hydrogen atom present in Z is. So C6H7N. C6H7N. Isn't it aniline? Isn't it aniline then? C6H5NH2. C6H7N. This is aniline. The compound is aniline. From the description, we can understand it is aniline. Right? You see that aniline is sparingly soluble in water. Correct? However, on addition of dilute mineral acid, it becomes soluble in water. Because when treated with the dilute mineral acid, you are getting anilinium chloride. You get anilinium chloride. Now it is soluble in water. You see the difference. Right. X, when treated with the chloroform and KOH, you get Y. So this, when treated with the CHCl3 and KOH, you will get isocyanide. You get isocyanide, benzene isocyanide, and this is Y. So this is X and that is Y. Now on treatment with the benzene sulfonyl chloride, this on treating with the benzene sulfonyl chloride. This is benzene sulfonyl chloride. Everybody remember Hinsberg reagent. Now this H and the Cl out. The product will be aniline benzene, then NHSO benzene. Okay, this is the molecule. And that's the compound Z. That is the compound Z. Now the question is number of different hydrogen atom in Z. Number of different hydrogen atom in Z. Let's see the number of different hydrogen atom. This is one type of hydrogen. And here we have a hydrogen. And here we have a hydrogen. These two are same. So this is one type. And these two are same type. So second type. And this hydrogen and this hydrogen are same type. Third type. These two are same. See how these two are different, because this is ortho position, this is meta position. Even the position can change the characteristic nature of that hydrogen when it undergo a chemical reaction. That's why it is different hydrogen. Now this is para position, there is a different hydrogen. So type 1, type 2, type 3, type 4. Similarly, coming on to this side, this hydrogen and this hydrogen are same. So another type. This hydrogen and this hydrogen are same, another type. This hydrogen, another type. So totally 1, 2, 3, 4, 5, 6, 7. I repeat, the different types of hydrogen. This hydrogen, one type, para position of this. This hydrogen, another type, these two are same, meta position. This hydrogen, another type, these two are same, ortho position. And this is acidic hydrogen, distinctly different, not in the ring. And coming to the other side, this ring is entirely different. This hydrogen and this hydrogen are same, another type. This hydrogen and this hydrogen are same, another type. This hydrogen. So total number of different types of hydrogen atom is 7. The answer is option 1, correct answer. Option 1, correct answer. Right? Clear? Next question. So the point is, from the description, we need to understand it is aniline. and aniline treated with benzene sulfonyl chloride, Hinsberg reagent. You are getting that product, analyze that product, and find out the different types of hydrogen atom present in that product Z. Okay, next. Question number 80, again a statement based question. Yes. Two statements are given. Let's analyze the statement. First one. You have 1,2-diamine, benzene 1,2-diamine synthesized from this molecule using similar reagents in the order acidic KMNO4, ammonia, bromine, alkali. This when treated with acidic KMNO4, you will get phthalic acid. You get phthalic acid. You see, this group will be converted to COOH. And that when treated with ammonia, you get phthalamide. And of course, on heating, you get CONH2, CONH2. That when treated with the bromine alkali, you know, it is a degradation reaction. Isn't it? And the result will be, no doubt, you get the result, this one. You get this result. So the statement 1 is correct. Statement 1 is perfect. The given molecule, when treated for oxidation, you get phthalic acid. Any substituted benzene, when you undergo oxidation reaction, you get benzoic acid. So there are 1-2 positions, 2 alkyl groups available. There is hydrogen. So definitely you are going to get a benzoic acid. And in fact, here it is benzene 1,2-dicarboxylic acid, popularly known as phthalic acid. So first you get phthalic acid. Reaction with ammonia, you get phthalamide. And the third reaction, Hoffman's degradation reaction, and you get that product. First statement is correct. What about second statement? The given molecule converted to this using the reagent. First bromine water. This will be converted to a bromine will come here and a bromine will come here. Actually, para position should be it's occupied. So the product will be para position already occupied by CH3. It remained there. You get a bromine here and a bromine here and NH2 here. So aniline, when treated for bromine water, you get 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. But here the fourth position is already occupied. So you get only 2,6. Now it is treated with NaNO2HCl. This is treated with NaNO2HCl. The result is ഇവിടെ CH3 ഉണ്ട്. Here you have bromine, and this will turn N2 plus Cl minus. You get diazonium salt. And then it is treated with H3PO2. This is treated with H3PO2. I am sure you remember the reaction. Diazonium salt treated with H3PO2. The diazonium group will be removed and you get a benzene as the result. So the result will be that diazonium salt will go. You get CH3 here and bromine here and bromine here. This group will vanish and you get H3PO2 converted to H3PO3. And that is the result. So that means statement 2 is also correct. So statement 1 correct, statement 2 correct. Statement 1 correct, statement 2 correct. Both are true. Option 3 is the correct answer. Both the statements are true. But to understand that, we need to check the whole lot of a sequence of reaction. That's what very important seems. Okay, let's go to the next question. Question number 81. Consider the following sequence of reaction. Assume that the reaction proceeds to completion. then 137 milligram of 4-nitrotoluene will produce dash milligram of B. That is our question. Okay. So starting with the nitrotoluene, ending with the what product and what milligram obtained. That is the question. Yes. Let's see. Let's see. So, what is the reaction actually? What reaction is actually? This treated with SnHCl. This treated with SnHCl. So, nitrobenzene, this group will be reduced to aniline. Everybody know. So, this CH3 remain as such. NO2 group will be reduced to NH2 group. NO2 group reduced to NH2 group when treated with SnHCl or iron HCl, right? Reduction of nitro group. Reduction of nitro group, you get aniline. Aniline. pH neutralization means neutral pH. Neutral pH, it will remain as such. So this is compound A. This is compound A. Now that is treated with acetic anhydride. That is acetic anhydride. So that is treated with acetic anhydride. You get acetanilide. Acetanilide derivative. You get acetanilide derivative. Isn't it? Yes, acetic anhydride. You get acetanilide derivative. This is what you get. And now it is treated with the bromine. Now it is treated with the bromine acetic acid. It's treated with the bromine acetic acid. You will get monobromination product. You will get monobromination product. There will be CH3 here and a bromine will come here and you have NHCOCH3. NHCOCH3. This is what the final product B. This is what the final product B. Now, starting with the 137 mg of this, how much you get there? Let us figure out what is the molar mass of this. C6H4 CH3 എന്ന് പറയുമ്പോൾ 15 ഇത് 76 and NO2 and it is NO2. NO2 means 14 plus 32. 32, 42, 46. 46. So that will come around 137. You get 137 molar mass of A. 137. What is the molar mass of this? Molar mass of this. It is CH3 part 15 and bromine part 80 and this part C6 H1 2 3 C6 H3 only plus this part NH 14 and this part it is 43 and this will be 75. So 75 15 75 plus 30 105 185 228. You will get 228 molar mass of the product here. 228. Please verify whether I made some mistake. Isn't it 228? So 137 molar mass here. Starting with this molecule, you are starting with 1 mole of this compound. You will end up with 1 mole of this compound. 1 mole of this means 137 gram. 137 gram of this will give you 228 gram of this. That means 137 milligram. You will get 228 milligram. 228 milligram. So 1 mole of nitrotoluene end up with 1 mole of our final product. There the molar mass 137. So 137 gram, you get molar mass here 228 gram. So 137 milligram, you will get 228 milligram. Option 4 is the correct answer. So we need to identify the sequence of reaction, check the molar mass of the starting material and the end material. That straight away. The final part of the question is very simple, and that sequence to understand is very, very important, right? And even calculating molar mass also will take time, and that we need to be pretty careful, especially in numerical type of question. Missing one hydrogen will make you lose the mark. Okay. In choice type question, it is pretty simple, or rather less risky. In numerical type question, finding the molar mass, when you miss one hydrogen, when you miss one atom, it's going to be highly risky. Yeah, exactly. Right. Next one. So here the first reaction, reduction of nitro group, you get aniline. Then acetic anhydride, you get acetanilide group. And then bromination, you get monobromination. It's not coming at para position, already occupied. It will coming at ortho position. And then check with the stoichiometric calculation. Next, the mass of benzanilide obtained from benzoylation reaction. Mass of benzanilide obtained from benzoylation reaction of 5.8 gram aniline if yield of product is 82%. Mass of benzanilide obtained from the benzoylation of aniline. That is Schotten-Böhmen reaction. NH2 treated with benzoylation, treated for, this is benzoylation, HCl out, and the reaction product is benzanilide. You get benzanilide, NHCO, benzene ring. Mass of benzanilide obtained from the benzoylation reaction, 5.8 gram aniline. 5.8 gram aniline if yield of product is 82%. So yield of product is 82%. Please understand, 1 mole will give you 0.82 mole. That is the point. See, the yield is only 82%. The yield is only 82%. 100% yield, 1 mole will be converted to 1 mole. 82% yield, 1 mole will be converted to 1 into 82 by 100. That is 0.82 mole. Now, how many moles here? 5.8 gram aniline. So 5.8 gram aniline molar mass 93. So 5.8 divided by 93 mole. 1 mole give 0.82 mole. Therefore, this much moles will give you 5.8 divided by 93 into 0.82 mole. Let us convert into gram. We want answer in gram. So what is the molar mass of this? We have C6H5. രണ്ടെണ്ണം ഉണ്ട് കേട്ടോ, ഇവിടെയുണ്ട്. അപ്പോൾ അത് 2 times എടുക്കുക. NH means 15. NH means 15 and CO means 12 16 28. This you can take the molar mass. Molar mass of benzanilide 197 എന്ന് കിട്ടും കേട്ടോ. Please verify. 197 molar mass of benzanilide. C6H5 എന്ന് പറഞ്ഞാൽ 77 into 2 154 plus 15 plus 28. You will get 197. So your answer will be, this is converted to mass, 5.8 by 93.82 into 197. That will be the answer. That will be the answer. Athrayum grams. That is the answer. Okay. The answer, please verify whether you are getting 10. 10 is the answer. Please verify whether you get that or not. 10 gram you will get. Once again, aniline treated with benzoylation, you get benzanilide. 82% yield of the reaction. What is the mass of benzanilide obtained by treating with 5.8 gram of aniline? Understand? 1 mole aniline, you will get 1 mole benzaldehyde, provided it is 100% yield. For 82% yield, 1 mole will give you 0.82 mole. This much mole will give you that much into 0.82 mole. Convert into grams into molar mass. Fine. Okay. Next question. Next. A is a neutral organic compound. A is a neutral organic compound. On treatment with aqueous, bromine and alkali, it forms compound B, which is soluble in dilute acid. B on treatment with aqueous NaNO2 HCl produces compound C. On treatment with the CuCN NaCN produces D. D on hydrolysis of D produces E, which is also obtainable from hydrolysis of A. E on treatment with the acidified KMNO4 produces F. F contain two different types of hydrogen atoms. The structure of A is. Suppose we take up first option. Suppose we take up first option. See this molecule. This is a neutral molecule, no doubt. This is a neutral organic compound, no doubt. Framing the formula perfect. On treatment, we see all the molecules you can see. This is neutral, this is neutral. All are neutral only. The molecule reacting with the bromine H2O, that is Hofmann's degradation reaction. That means this choice is out. Hofmann's degradation reaction applicable to primary amides, CONH2. So it can be this one, or this one. No problem, no problem. So anyway, I'm taking option 1. This when treated with the bromine with the alkali, you will get Hofmann's degradation reaction. And you get metatoluidine. Imagine this is A and this is B. Metatoluidine. This is soluble in dilute acid, correct? This is soluble in dilute acid. This is treated with NaNO2 HCl, you get C. So this is treated with NaNO2 HCl, you will get diazonium salt, N2 plus Cl minus and CS3. This is C. And that treated with the CuCN NaCN Sandmeyer's reaction. That is treated for Sandmeyer's reaction, CuCN NaCN. You will get Sandmeyer's reaction. This is what D. This is what D. Hydrolysis of D produces E. This when hydrolyzed, you will get CN turn COOH. This is what E, which is also obtainable from hydrolysis of A. It is also obtainable from hydrolysis of A, correct? This upon hydrolysis, you get CONH2 converted to COOH. Perfect. E on treatment with acidified KMNO4 forms F. This when treated with KMNO4, oxidation reaction, you get isothalic acid. You get isothalic acid. This is F. F contain two different types of hydrogen atom. F contain two different type of hydrogen atom. Let's see, that is the triggering, that is the important final conclusion regarding the answer. This contain two different types of hydrogen atom. It contain this hydrogen are same. This hydrogen is different. So type 1. This hydrogen and this hydrogen are same. So one type. This hydrogen, another type. This hydrogen, it's a different type. This hydrogen in between these two groups, which is different from this hydrogen, which is away from this. And this hydrogen and this hydrogen are same. This hydrogen and this hydrogen are same. And this hydrogen is different, right? This hydrogen, it is different. It is different, right? So this hydrogen ortho position to this, ortho, these two are same. So this is a, so there are anyway, there is not two different hydrogen. There is more than two different hydrogen. 1, 2, 3, 4 it seems. 4 it seems. More than two types of this. So answer is not option 1. Answer is not option 1. What about option 3? Option 3, when you do the similar procedure, you will end up with a COOH here and COOH here. Suppose you take up option 3. If you do the similar procedure, you will end up with the thalic acid. How many different types of hydrogen here? Is it 2 type or not? This and this are same. This is a different one. Now this is another one, isn't it? Idinte meta, idinte ortho, idinte para, idinte meta. This is a different hydrogen, isn't it? Idinte meta, idinte para. It seems these two are identical. It seems these two are identical. I think these two are identical and these two are identical, isn't it? Anyway, one type, two type, there are 3 types. Anyway, more than 2 types is present. More than 2 types is present. These two are one type. This is one type and this is another type. There are 3 types, it seems. Okay. What about, you are not getting the answer. Maybe in 4th choice. Yes, in 4th choice, we will get the answer. In 4th choice, we will have the answer. Please have a look at. In 4th choice, you have COOH here and COOH here. How many types of hydrogen? This type and this hydrogen are same. Now, this hydrogen, this hydrogen, this hydrogen, this hydrogen, all are same. So, this one type, these two are same. This hydrogen, all are same. So, there are 2 types of hydrogen in this molecule and the answer is 4th option. Answer is 4th option. Please understand, when you have a substituent in the benzene ring, the hydrogen are different in the benzene ring, right? If you have one substituent, that's very important point to be understand. If you have a substituent here, please understand how many types of hydrogen are available. This hydrogen and this hydrogen are same. Now, this hydrogen and this hydrogen are same. Now, this is another. There are 3 types of hydrogen when benzene carry one substituent. Ortho hydrogen at ortho position, hydrogen at meta position, hydrogen at para position. I am sure all of you remember the relative substitution at these 3 positions are different. That means that hydrogen is different in nature, in its bonding at 3 positions. And that is what the basic fact in the question. So, analyzing the entire sequence, it is applicable to first choice, third choice, and fourth choice. Because that reaction sequence is perfectly matching for all the three choices except third choice. Except second choice. Second choice is a secondary amide that is out. Now, all the other choices, it is perfectly matching for the entire sequence. But last part of the question, there are two types of hydrogen in the final molecule F. That is satisfied by one option, and that is fourth option. Fourth option is the correct answer. This is the correct answer. Is that clear? Fine. Next, 84th question. Yes. An organic compound P on treatment with aqueous ammonia under hot condition forms compound Q, which on heating with the bromine KOH forms compound R, having molecular formula C6H7N. Name P, Q, R respectively. Option A, phenyl ethanoic acid. Phenyl ethanoic acid. Phenyl ethanoic acid. pH CH2COOH. Treatment with the aqueous ammonia under hot condition. You get pH CH2CONH2 amide. This is P and this is Q. On treatment with the bromine KOH, you get pH CH2NH2. This is R. R having formula C6H7N. Wrong. This is C7. This is C7. First option is out. Second option, benzoic acid. Benzoic acid will give you, this is P, will give you pH CONH2, that is Q, and that with the bromine KOH you get pH NH2, that is R. That is matching with the formula. Option 2 is the correct answer. Option 2 is the correct answer. If you take option 1, the reactions are perfect, but the final product R doesn't match with the formula. While the second option, it is matching with the formula, you get aniline. C6H7N means aniline. So the reaction is benzoic acid. Benzoic acid treated with the ammonia and heating. You get benzamide, that is Q. Benzamide with the bromine and alkali. You get a degradation reaction, Hoffman's degradation reaction, and the CO is out. You get pH NH2, aniline. Aniline is what the formula given. Second choice is the correct answer. Clear? You may please verify third and fourth, how it's not becoming the answer. Okay. അടുത്തത് structure of 4 disaccharides are given below. Among the given disaccharides, non-reducing sugar. We want to know non-reducing sugar. What is a non-reducing sugar? The sugar which does not reduce Tollens reagent, the one which does not reduce a Fehling solution, that is what called a non-reducing sugar. All monosaccharides are reducing sugar. Disaccharides such as maltose, lactose are reducing sugar, and the popular non-reducing sugar is sucrose. Sucrose. You can see here we have free functional group available. Here we have free functional group available. It will open up and it can reduce Tollens reagent. Answer is second choice. Here you don't have the functional group free. Here the functional group is locked. this functional group and this functional group, it is locked by glycosidic linkage. This is the non-reducing sugar. While here, this area is open. You see, this functional group is free and it can reduce. Here, this functional group is free, it can reduce. So, option 2 is the correct answer. Option 2 is the correct answer. There, you don't have any functional group which is free to reduce. Right? Non-reducing sugar. Simple question. അടുത്തത്. In the given pentapeptide, find out an essential amino acid Y and the sequence present in the pentapeptide. An essential amino acid Y and sequence present in the pentapeptide. What sequence is present in the pentapeptide? Okay, that is what the question. So 1, 2, this is 3 and this is 4. Okay. So let us analyze the various amino acids. So this is number 1. This is number 1. Fine. And this is number 2. This is number 3. Again, this is number 4. And finally, pentapeptide. This is number 5. That is number 5. Right? We need to analyze what all amino acids are present. What all amino acids are present there. Right? And out of which is a essential amino acid. We need to know the essential amino acid Y. Hope you know what is meant by essential, non-essential amino acids. There are amino acids which are produced in our body. Non-essential amino acids, the one which we need to take through the diet, that is essential amino acid. Out of 20, 10 amino acids are essential, 10 are non-essential amino acid. Let us understand what is the first one. First one, I hope you understand, it is threonine. Without knowing the structure, you can't answer this. Please understand. First amino acid from the left. Hope you know. That is threonine. This is threonine. Have a look at which is a essential amino acid. Threonine. CH3 CHOH group. CH3 CHOH group. This is threonine, which is an essential amino acid. This one. CH3 CHOH group. I am talking about R group. R group is CH3 CHOH group. This is R group. Everybody remember. It's nothing but threonine. It is nothing but threonine, which is an essential amino acid. So threonine Y is correct, and starting with the threonine is correct. This is starting with the serine. This is starting with the threonine, but serine given. So we got the answer. Simply analyzing the first amino acid, we get the answer. We are starting from the left side. We are starting with the threonine, and that itself is essential amino acid. So we get the answer. First option as correct. Straight away we get the answer. First option as correct. Let us verify the other. Second one, serine. Isn't it correct? Second one, serine. Here you have serine available here. This one. CH2OH group. R part is CH2OH group. You see this. This is serine. R part. It is CH2OH group. Serine. This is serine. Now, third one. Next. that is CHCOOH. CHCOOH. CH2COOH, aspartic acid. Look at this, R group, CH2COOH, right? Aspartic acid. This is aspartic acid, CH2COOH, aspartic acid, ASP. Then glycine, that's a very simple first amino acid, glycine, CH2 group. This is glycine. And alanine, CH3CH2 group, alanine. In fact, understanding the first amino acid and understanding that is essential amino acid, we finalize the answer. Anyway, the nature of the question or the basis of the question is very, very important. Whether you have practiced knowing, understanding the structure of amino acids, that is the matter of fact. Okay. You need to understand regarding amino acid, you need to know the structure of amino acid, the nature of amino acid, whether it is acidic, basic or neutral, whether it is essential amino acid or non-essential amino acid, what kind of functional group entity is available in that amino acid. That is also very important. Sometimes they may ask a question like which of the following amino acid can give you a test with neutral ferric chloride. The point is very simple. They are asking which contain phenolic group present. Which amino acid contain a phenolic group is present. Which amino acid when treated for Lysines test, you get the combined test of nitrogen and sulfur together with the ferric chloride giving a blood red colored ferric thiocyanate. That means they are trying to ask you which amino acid contain. Of course, we know amino acid contain nitrogen. Which amino acid contain along with the nitrogen, it contains sulfur. So these kind of possibilities based on the structural details of amino acid, you should expect one question. It's a simple question, but you can't answer if you don't know the structural details. Okay. Adutha chodyam. 87. Yes. Number of possible tripeptides formed involving alanine, glycine and valine, where no amino acid has been used more than once. No amino acid used more than once. Okay. That is simple, no? That is simple. Alanine, glycine, valine. So you have three different amino acids, A, B, C. How many possibilities are there without repetition? So it is 3 factorial. It is 3 factorial. 1 into 2 into 3. That is 6. Option 4, 6. What is the possible combinations? You can have ABC. You can have ACB. Right? You can have BAC. You can have BCA, you can have CAB, you can have CBA, 6 combinations without repetition. With the repetition, it will be many more. With the repetition. Without repetition, you will get 6 combinations. Very simple question. Yeah. But a very important question came multiple times. Right. Next. Question number 89. Both human DNA, RNA are chiral molecules. The chirality in DNA, RNA arises due to the presence of chirality of DNA, RNA. Everybody know DNA, RNA contain a nitrogenous base, purine, pyrimidine bases. There is a pentose sugar and phosphate group that together makes a nucleotide. Polynucleotide is DNA and RNA. Polynucleotide is DNA, RNA, isn't it? So, DNA, RNA are chiral molecules. What lead to the chirality? Is it D sugar component, L sugar component, phosphate chirality, or base unit? The answer is no doubt D sugar component. D sugar component. There are sugar moiety present, and that is chiral molecule. Nitrogenous base is not chiral. Phosphate unit is not chiral. Chiral system is that sugar moiety. In DNA, you have deoxyribose sugar, and RNA, you have ribose sugar, which lead to the chirality in overall DNA molecule. It is due to that sugar moiety. Okay. And once again, option 1 and 2, there's a possibility of committing mistake. Is it D sugar or L sugar? It is D sugar only. It is D sugar only. And this is in DNA. This is present in DNA, deoxyribose. And this is present in RNA, ribose sugar. And how many stereo centers are possible? How many stereo centers are possible? Have a look at. 1. The number of stereo centers. Number of stereo centers that are possible. The number of stereo centers that are possible. You see, 1, 2, 3, 4 in ribose, and 1, 2, 3 in deoxyribose. This loses the chirality. That is prochiral. Prochiral. So in ribose, there are 4 stereo centers, and deoxyribose, there are 3 stereo centers. Right? All these things are studied only. Okay. Next. So the answer is first one. It is D sugar. It is D sugar, not L sugar. It is D sugar, not L sugar. Question number 90. From the given following A to D cyclic structures, those which will not react with the tolerance reagent. The one which will not react with the tolerance reagent. That means non-reducing in nature. Non-reducing in nature. That is the question. Let us figure out one by one. A is a reducing sugar. This area, it will open up, and you will get a free functional group that act as a reducing sugar. B will not. B will not. Please have a look at. In B, this is a non-reducing part. It will not open up. It will not give you a free functional group, as it is OCH3. That is a non-reducing sugar. What about C? C also, it is non-reducing in nature, while D, it is reducing in character. It is so in option A and D, the functional group will break, and you will get free functional group, and it can reduce tolerance reagent, reducing sugar. While in B and C, this area cannot open up, and you don't get a free functional group available to reduce tolerance reagent. Answer is B and C. Very simple question once again. It's option B and C, where you don't have the functional group available in that region which can reduce tolerance reagent and act as a reducing sugar. Okay. Because of this OCH3 available, this OCH3 is the reason. This is the reason. OCH3, this group. That is the reason. This group is the reason. Okay. Next. Yes, exactly. Next. You have a matching. You have a matching the list. Reaction of glucose with and the product formed. Reaction of glucose with and the product formed. So hydroxylamine, you get oxime. Hydroxylamine, you get oxime. A matches with 4. A matches with 4. Then bromine water, you get oxime. hydroxylamine reaction, hope you remember, CHO, CH2OH. It is reacting with the hydroxylamine. It is reacting with the hydroxylamine. It is reacting over here. You get oxime. CH double bond NOH. This is oxime. Now bromine water, glucose with the bromine water. Glucose with the bromine water, you get gluconic acid. This group will be converted to COOH. This group will be converted to COOH called gluconic acid. So B with 1. We get the answer. A and B will give you the answer. A and B will take you to the answer. A4, B1. What about C, D? Is it C2 correct? C2, excess of acetic anhydride. You get pentacetate. Glucose contained. CHO, CHOH 4 times, CH2OH. There is 5 OH group, 4 over here and 1 over here. You will get pentacetate known to everybody. C2 is correct. And D3, concentrated nitric acid, you get succaric acid when glucose treated with concentrated nitric acid. The point is this group and this group will be oxidized. You get COOH, 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 CH2OH 4 times. You get succaric acid. This is called a gluconic acid. So glucose with the mild oxidizing agent, glucose with the bromine water, you get gluconic acid, and glucose with the strong oxidizing agent, you get succaric acid. Studied reaction, textual reaction only, and simple matching once again. Fourth choice will be the correct answer. Okay, next. 93rd question. 93rd question. Statement based question. Statement based question. First one. Sucrose is dextrorotatory. However, sucrose upon hydrolysis gives a solution having mixture of product. This solution shows levorotation. Correct? Statement 1 is correct. Isn't it? Statement 1 is correct. Statement 2. Hydrolysis of sucrose gives glucose and fructose. Since the levorotation of glucose is more than dextrorotation of fructose, the resulting solution is levorotatory. This part is wrong. This part is wrong. It's a wrong statement. Hydrolysis of sucrose gives glucose and fructose, and the obtained product is levorotatory. Why it is levorotatory? You see, sucrose upon hydrolysis, you get glucose and fructose. This is dextrose. This is dextrose, while the obtained product is levulose. Obtained product is levulose. And out of the product, this is dextrose and this is levulose. Then how come the mixture levulose? This is levulose because of more levorotatory of fructose. The obtained product, which is so-called invert sugar. The product of sucrose hydrolysis is called invert sugar. It's called invert sugar because sucrose dextrorotatory converted to levorotatory product. That product contains equimolar mixture of glucose and fructose, of which glucose is dextrose, fructose is levulose. The mixture is levulose. How the mixture is levulose? Because the levorotatory of fructose comes in the range of -90, close to -100 degree, while the dextrorotatory of glucose is coming +50 degrees something, 52 or something. So levorotatory nature of fructose is more than the dextrorotatory. It's actually a opposite statement is correct. This is wrong. Levorotation of glucose alla, levorotation of fructose is more. Therefore, the product is levorotatory. So, second statement is wrong. The answer is First true, second false. First true, second false. Option 2 is the correct answer. Okay, fine. Next, question number 94. Four statements are given. We need to identify the correct statement. Four statements are given. We need to identify the correct statement. Let's check option A. Statement A. Activation energy for enzyme catalyzed hydrolysis of sucrose is lower than that of acid catalyzed hydrolysis. Correct? Correct. Textual statement. Enzyme catalyzed hydrolysis is happening pretty more fast than acid catalyzed hydrolysis. So activation energy lower for enzyme catalyzed. Correct. Option B. During denaturation, secondary, tertiary structure of proteins are destroyed, but primary structure remain intact. True statement. Both we can find in the textbook. It is there in the textbook. Nucleotide are joined together by glycosidic linkage between C1, C4 carbon of the pentose sugar. That is wrong. This is wrong. Nucleotides are joined together by glycosidic linkage between C1, C4 carbon of pentose sugar. Wrong. How the nucleotides are connected? How the nucleotides are connected? This is how nucleotides are connected. This is one nucleotide and this is the next nucleotide, and they are connected by not glycosidic linkage. It is by phosphodiester linkage. It's by phosphodiester linkage. This is the linkage. And how it is making the linkage? C3 carbon of one pentose sugar with the C5 carbon of the next pentose sugar. So two nucleotides are connected by phosphodiester linkage, high energy linkage. That is the energy area. Okay, and that is connected through the C3 carbon of one sugar moiety with the C5 carbon of the next sugar moiety. Right? So that statement is wrong. Third statement is wrong. Nucleotides are joined together by glycosidic linkage between C1, C4 carbon of atom of both are wrong. Now, quaternary structure of protein represent overall folding of the polypeptide chain. Wrong. Quaternary structure means, see, overall folding of the polypeptide chain is tertiary structure. Overall folding is called a tertiary structure. Quaternary structure means overall folding including the subunits. Two different folded units together is called a quaternary structure. Primary structure means a specific sequence. Coiling of that sequence is called a secondary structure. Further coiling is called a tertiary structure. Including the subunits is called a quaternary structure. Okay. So the answer is A and B. Getting the first statement, this is out. Getting the second statement, this is out. And getting third statement, we don't get the answer. Fourth statement, analyzing all the statement, you get the answer, no doubt. Answer is A and B. Okay. Now, question number 95. Question number 95. Arginine and tryptophan are essential amino acids. Arginine and tryptophan are essential amino acids. A is true statement. Arginine and tryptophan are essential amino acids. This is arginine, which is an essential amino acid. Tryptophan is also essential amino acid. I am sure everybody seen the table in the NCERT. This is from the table of NCERT. There is asterisk given, there is star mark given for identifying essential amino acids. So arginine and tryptophan are essential amino acid, no doubt. Option B, histidine does not contain heterocyclic ring in its structure. Histidine does not contain heterocyclic ring in its structure. You see histidine, this is histidine and there is a heterocyclic ring in the structure. It is wrong statement. It is a wrong statement. So A correct, B wrong. A correct, B wrong. A correct, this is out. B wrong, this is out. This is out. We get the answer straight away. Checking 1 and 2 option, we get the answer. Checking 1 and 2 option, we get the answer. A correct, B wrong. A correct, B wrong. There is no A, there is B, out. So A and D. What about C? Proline is a 6-membered cyclic ring amino acid. Proline is a 6-membered cyclic amino acid. This is proline. This is proline. That is not a 6-membered. 1, 2, 3, 4, 5-membered ring only. It is 5-membered ring only, not 6-membered. It is wrong. Glycine does not have chiral center. We know that glycine does not have chiral center. This is glycine, NH2, CH2, COOH. This is glycine and this is not chiral center. This is prochiral center. In the carbon in glycine is not chiral center, it is prochiral center. There is no chirality. D is correct. E, cysteine has characteristic feature of side chain. MES, CH2, CH2. Cysteine. Cysteine have MES, CH2, CH2. That is for methionine. The comment is true for methionine. For cysteine, it is CH2SH. The comment is true for methionine. That means this is also wrong. So A and D only. Okay, fine. And that was the last question. That was the last question, right? So nearly 100 questions. 95 questions from all sessions of the latest finished JEE examination. So we have discussed all 95 questions in detail. Each and every option in detail we have discussed. In the organic chemistry part, we have included 3 different videos. The chemistry part of 2026 JEE Mains Phase 1 examination held on January. The entire session of questions, chemistry part, we have split it into 3 videos. One for physical chemistry, one for organic chemistry, one for inorganic chemistry. So this video will contain a conclusive all questions organic part, irrespective of first year, second year, irrespective of the chapters, all organic part is dealt in this video. Please go through the entire questions dealing in organic chemistry, right? And feel free to get in touch with any further details, any further queries, any further doubts on any part of these or more. Okay, we'll meet with another class in another video. Till then, bye, see you, take care. In this video here we wind up the entire organic chemistry questions of the JEE Mains 2026 Phase 1 held in January. Thank you. Meet again.